Hey guys, welcome to question MM191 of the Maths Methods Fortify study guide. So, in this question we've got this function f of x equals tan x over 2x plus 1. We're challenged to find f dash of pi on 3. So guys, our first thing is to recognize that whenever we've got an f dash, that means that we need to derive or differentiate the original function. So before we can find f dash of pi on 3, we actually need to find f dash of x, okay? And then we can sub in pi on 3 for our x. So how do we differentiate this? Well, what we really need to look at is this fraction separator, the vinculum I think it's actually called. But this tells us that we're going to need to use the quotient rule to derive this, okay? So our quotient rule says that f dash of x, actually, you know what, let's rewrite this first. So f of x, so let f of x equal u over v, where u is equal to tan x and v is equal to 2x plus 1. So guys, our u is always our top function, our v is always our bottom function. And from here, we know that f dash of x is equal to v times du dx minus u times dv dx all over v squared. Now this is just our simple quotient rule. This should be on your formula sheet actually. So if you're not too sure of it, just check it out on there. Now, our next step is to find du dx and dv dx. I usually like doing that first. I don't know why I wrote that there, but we can still find it here. So du dx, the derivative of tan x is sec squared x. Now that should also be on your formula sheet. dv dx is simply just 2. So 2. Awesome. Now from here we can just simply plug in our values. So that means that f dash of x is equal to v, which is 2x plus 1, times du dx, which is sec squared x. Put that all in brackets. Awesome, and then take away u, which is tan x, times dv dx, which is just 2. All over v squared, where v is 2x plus 1 squared. Awesome. Now, I would like to rewrite this. You don't have to, but I will, just to kind of get rid of the brackets and multiplication signs. Take away 2 tan x, and that's all over 2x plus 1 squared. Now this is, in this case, a 3-mark question. There are definitely 3-mark questions like this on the VCAR exams. It's a little hard to tell where you might get these marks, but I like to say that you'll probably get your first mark around here, because you've identified that it's the quotient rule, you've found all these values and you've plugged them in, and then you'll get your second mark halfway through this working, and then you'll get your last mark for the answer. So we know that f dash of x is equal to this, which means that f dash of pi on 3 is equal to all of this, but just with pi on 3 subbed in for x. So 2 times pi on 3 plus 1 times sec squared of pi on 3. It's going to get pretty messy, guys. 2 tan of pi on 3 all over 2 pi on 3 plus 1 squared. Alrighty, so from here then we can just evaluate. So we get 2 pi on 3 plus 1. Sec squared of pi on 3 is the same as 1 over cos squared of pi on 3, right? So let's actually just rub this out up here. So we know that cos of pi on 3 is equal to 1/2, all right? Sec of pi on 3 is equal to 1 over cos of pi on 3, all right? So 1 over cos of pi on 3. We know that cos of pi on 3 is 1/2. So 1 over 1/2, which is equal to 2, right? So sec of pi on 3 is equal to 2, which means that sec squared pi on 3 is equal to 2 squared, which is 4. So this sec squared pi on 3, this section here, is a 4, right? So we're going to times that by 4. minus 2 tan of pi on 3. Tan of pi on 3 is equal to root 3. So 2 root 3 over, now I'm going to, oh, you know what, I won't do that yet. 2 pi on 3 plus 1 squared. Awesome. I'm just going to rub this out again. Come back here. So from here, we just need to kind of evaluate this. So I'm going to merge all of this into one fraction and all of this into one fraction, just to make it a bit kind of easier for ourselves. So then we get 2 pi plus 3 over 3, right? So I've changed this 2 pi over 3 plus 1 into 2 pi plus 3 over 3, right? Because here we have 2 pi over 3 plus 3 over 3, which is just 1. We're multiplying that by 4. And the reason I'm doing this, guys, is because we've got a fraction within a fraction, and we've actually got another one here as well. We don't like that. And the only way to kind of get rid of it without using a calculator is to get everything in a fraction, and then you can divide like fractions. So then take away 2 root 3 over, and same deal here, guys. So here we're going to get 2 pi plus 3 over 3 squared, okay? And again, we're doing this because we want just clean fractions. So from here, what we're going to do is just times that 4 in there, which means we get 8 pi plus 12 over 3 minus 2 root 3 all over, I'm going to actually separate these out. So 2 pi plus 3 squared over 3 squared, which is 9, okay? Now, this is about, I think, where you would get your second mark. So it's like somewhere in here you would get that second mark, first one being over here, like I said before. From here, the only thing that's left that isn't in a fraction is our 2 root 3 here. So we're going to actually merge that with this fraction over here. That means we get 8 pi plus 12. Now, we want the fraction of this to have a denominator of 3, so we're going to multiply that by 3 as well, which means we take 6 root 3 all over 3. All right, so what I've done is this little section here is this. And then we've got our big fraction divider over 2 pi plus 3 squared over 9. So now we've got two fractions dividing by each other, which means that we can actually flip them and multiply them, okay? Because keeping in mind that we don't have our calculator here, so we're gonna have to do a bunch of stuff that we probably wouldn't normally have to do in the calculator version. So from here, we know that we need to flip and multiply. So we get 8 pi plus 12 minus 6 root 3 over 3 times, and this fraction here, because we're dividing that fraction by that fraction, we're going to flip that and multiply. So we get 2 pi plus 3 squared. Awesome. From here, these this 3 and this 9 can cancel. That becomes a 3, that becomes a 1, which means we get 3, 8 pi plus 12, take 6 root 3, over 2 pi plus 3 squared. And that is our f dash of pi on 3. This is your third mark, guys. I know this is a really messy question, but you will get questions like this in your exam, and you'll just have to deal with it when it comes. So guys, if you have any questions, please hit me up in the comments below, but otherwise have a great day.